people manage an application that has some kind of login in it, whether it's for public users or admins or anything like that. So a good number of people. So what I'm going to do for you today is talk about how do we scale authentication with our Angular architecture. And I feel like I could probably skip these intro slides because I already received a very robust introduction. But I'm a GDE, and I'm also the head of DevRel at a company called Auth 2.0. Now, Auth 2.0 is what we call Identity as a Service, or IDaaS. It's basically a cloud platform that helps you to authenticate users and protect your data and your APIs. So basically, it's a system that deals with the complexity of authentication and authorization so that you don't have to. So here's a situation that comes up a lot when people are going to tackle an authentication project. The team they've been given the mandate to add login to the application. They're ready to get started, and then their lived reality ends up looking something a little bit more like this. So when you tell your team to start an authentication project, they might have some sort of very vague idea about what they might need to look up. They can go and they can Google, let's Google authentication. And then the thing is, you can actually get to here. You can do this thing where you draw the rest of the owl in basically just 2 steps by using an IDaaS solution like Auth 2.0 or a similar product. And it really can be that easy. But you as a leader can really facilitate the success of your team if you understand some more of sort of the challenges and the interim steps and the background that goes into getting to this finished product. So basically, I'm going to start with an introduction to identity. Now, when I tell people I work in identity, there's a couple of assumptions they usually make right off the bat, and that is, oh, I work at the Secretary of State issuing driver's licenses, or maybe I help people deal with identity theft or recover from credit card fraud. Neither of these are accurate. I work in digital identity. And what this is basically referring to a set of attributes that define an individual user within the context of the function delivered by a particular application. That's sort of a bunch of words randomly smashed together. It doesn't have really a whole lot of meaning by itself. But let me give you an example. So let's say that your company makes an application that is for selling shoes online, an online shoe retailer. Then the digital identity of your users, it might be something like their credit card number, their shipping address, and maybe their purchase history, the list of the last 10 pairs of shoes that they've bought. So another thing that comes up a lot when we talk about identity is authentication. Now, what do we mean when we say this? Well, in sort of a broad sense, authentication really refers to the process of verifying that the user is who they say they are. And then once we have that, we come to this other term, which is authorization. And authorization is really about granting or denying access to certain resources that your application provides. Now, when it comes to identity as a whole, if we want to achieve something like really good scalability, then one of the first places we should start is with open standards. And there's a few reasons that we should do this. So open standards are written and also stewarded and sort of caretaken by groups of experts in applicable fields. They're also supported and implemented very widely across the internet. So if you want to integrate with other services, it makes it a lot easier to do that if you're following open standards, and so are they. Standards are also updated as the web and the internet changes over time. And along that vein, they provide guidance for best practices on how you should deal with authentication and authorization. So when it comes to open standards in the landscape of identity, this is one that comes up a lot if you say standards for any kind of identity thing on the web. A lot of developers might say, oh, OAuth 2. Like, that's the first thing that comes to mind. But in order to kind of talk about what this even is, I want to address why it came about in the first place. So OAuth version 1 was established in December of 2007. And before that time, if we wanted to access third-party resources from one application in another application, then we had to do something like this. And you will probably actually recognize this from a little ways back. Hopefully not from super recently, but I have seen applications do this now too. So let's say, here's a scenario. You're a user and you use a web app called Hire Me to do your hiring, to find candidates, have them apply, set meetings on their calendars, so on and so forth. Let's say you also use another web app called MyCal app, and this is the app you use to manage your own calendar. Now let's say that Hire Me wants to be able to add an event to your MyCal. You want to set up an interview with a candidate, and you want it to be added to your MyCal. Now, before OAuth standards existed, what would happen would be Hire Me would come to you, and it would ask you for your credentials for MyCal. It would say, what's your username and password for MyCal? You would then give your MyCal username and password to Hire Me, which is a completely different application, and then Hire Me would use your credentials in order to be able to instruct MyCal to create calendar events on your MyCal calendar. And it did this using the access that you provided by giving Hire Me your MyCal credentials. Now, I hope that it's sort of generally universally known that sharing credentials is bad. This approach relied on giving personal, private information from you for one app to a completely different application. This is just not a good idea in general. But there's a few reasons why this is especially impactful in this scenario that we're sort of talking about here. First of all, Hire Me has a lot less skin in the game in this scenario. So if they don't do their due diligence with protecting those credentials that you gave it your MyCal credentials. And if they are like, well, you know, we're not MyCal, so we won't need to store these credentials super securely. We're just going to use them to access this other app. And then they get leaked. Then Hire Me might get some bad press. It might take a little bit of a hit to their branding, but it's not going to be catastrophic for them. It is catastrophic for MyCal, though. They just had their credentials leaked by a third party, and now all of their users are at risk if they were sort of interacting with Hire Me in any way. Hire Me also has way too much access to MyCal. You gave Hire Me your MyCal credentials. That means Hire Me can do anything in MyCal that you can do. So if you just wanted to be able to add an event to the calendar, well, now Hire Me can actually do everything else. Like it can read all of your other calendar events. It can delete events. It can change your settings if it wanted to. So this is kind of how OAuth standards came to be, was to address this problem. Now I'm going to specifically talk about OAuth 2.0 because that's the version that we're on right now. And OAuth 2 is an open standard for performing what we call delegated authorization. Basically, using OAuth 2 standards, what we can do is we can grant third-party access to APIs, resources from one application to another without exposing credentials or asking for credentials from a different application. And the manner in which this is done is with something called an authorization server. Now, this is really just kind of a fancy word for a set of endpoints whose purpose is to interact with the user and to issue artifacts called tokens. So if we come back to our scenario now, what this would look like with OAuth 2 is we have Hire Me, we have MyCal, we have the user in the middle, and now if we are going to be using OAuth 2, then MyCal has this thing called an authorization server. Let's say the user's already logged in with Hire Me. That's kind of outside of the scope of OAuth. Would just say that they're logged in, Hire Me knows who they are, and they've sort of got it all squared. Their identity is squared away with Hire Me. Now Hire Me wants to set a calendar event on your MyCal. What it's going to do this time is Hire Me is going to tell the MyCal authorization server, hey, I want to access your resources. The MyCal authorization server is then going to come to the user, and it's going to prompt the user to log in with MyCal. So nothing sort of strange is happening. MyCal is asking the user to log in with MyCal. That's not weird. The user is going to authenticate with MyCal. And then the MyCal authorization server is going to prompt the user to give the user's permission to allow Hire Me to access MyCal in order to do this thing that you want to do, to add this event to the calendar. And not any more than that, only that. Can Hire Me add an event to your calendar? That's what it's going to say. And then if you say yes to this, then the MyCal authorization server is going to send a code to HireMe that says the user said this was okay. And then HireMe is going to take that code, and it's going to send back its own identifying information to say, yes, I am HireMe, you trust me, you know that I'm going to be asking for access, and we can have this exchange. Then MyCal's authorization server, if everything checks out with that, is going to issue what we call an access token. And this is an artifact that HireMe can use in order to send to MyCal to tell MyCal to do something on its behalf, but only within the scope of the permissions that were accepted by the user. So if the user said, okay, you can add events, then this access token that HireMe has is only going to allow HireMe to add events, and that's it. So at this point, HireMe can set calendar events for the user by using the MyCal resources. So as you can see, there's nothing insidious happening now. MyCal's asking the user to log in with MyCal. HireMe is not asking for the user's MyCal credentials. And HireMe can only do what the user said they could do. They could only create events, can't read all of the events, can't change any settings, can't delete events, anything weird. So the issues that we had with sharing credentials, as well as the problem of too much access, this just no longer is an issue. It's basically been solved. But the thing that happened then was that applications wanted to do more with this than just access resources. They wanted to be able to log users in with accounts that actually lived in other systems. So maybe HireMe wants a MyCal user to be able to log into HireMe using their MyCal account, even if they don't have a HireMe account. And you've probably seen this if you have something that says you can log into this other application with Google or Facebook or Twitter or something like that. That's what this is. It's what people wanted to do. But OAuth 2 is a specification for delegated access. It's not an authentication protocol. The thing is, if HireMe wants to do something like use this access token, we have this access token that MyCal gave that allows us to access resources. And if HireMe thinks that by having this token, it means that the user can be considered authenticated with HireMe, then we're going to run into problems. The problems that we run into here are that someone could have stolen this token. We actually don't really know whose it is. The token could come from a completely different user, not the user that's currently looking at the browser. It could have been obtained from a different application that wasn't HireMe, and then just injected into HireMe. And we call this the confused deputy problem. HireMe doesn't know where this token came from or who it was issued for. It just knows that by having the token, it means it can access MyCal resources. So if we think back to what was the definition of authentication? Well, it was about verifying that the user is who they say they are. And HireMe just can't know this from the presence of this access token. This didn't stop people from doing it anyway, and they would run into this confused deputy problem, and there were security issues with this. So in order to sort of meet the needs of the scaling challenge and the demands of everybody who was producing applications on the web, who wanted to be able to sign in with different services in their apps, then this is how another specification was born, and this is the OpenID Connect standard. Now, OpenID Connect, or OIDC for short, is an identity layer on top of OAuth 2 that tells us how to authenticate users using that same authorization server. So again, to be really clear, OAuth 2 is about delegated authorization. OpenID Connect is authentication. OAuth 2 doesn't deal with authentication. So if people say authentication with OAuth 2, it's an erroneous statement. It's not correct. So we know that the authorization server is capable of issuing tokens. And it can actually issue several different types of tokens. And this includes ID tokens, which contain identifying information about the user. And this is for authentication. It can also issue access tokens, whose purpose is to grant access to resources. And this is authorization. So why is identity so complex? I sort of gave a high-level overview of these general terms and concepts. It seems like once you kind of grasp that, then maybe you have a pretty good understanding. But the thing is, the standards like OAuth 2 and OpenID Connect, they're very well defined. They're good standards, but they're also extremely dense. I don't know if anybody has ever opened them up and looked at them or tried to read them. Nobody? That's probably good. You probably shouldn't have to. But if you were giving your team a task of implementing this and they had to go read the standards, they're very hard to get through. There's a lot of different flows. There's a lot of different solutions that are challenging to understand and implement safely and securely if you're not an expert, if you don't really know what you're doing, if you don't understand the jargon. And most developers in general do not. So if your team doesn't have this deep understanding of identity, then they're going to have trouble knowing how to interpret and act on the recommendations given by the specifications. The other thing that we have to take into account is scaling requirements when we do identity. So these are just a small handful of demands of identity as your applications scale. These are all common needs. None of them are super unusual or weird. But what this does is it emphasizes the need for a scalable, robust way to handle identity. Because you don't want, when you're going from 100 users to 100,000 users, you don't want to get all hung up in the fact that, oh, now we need all of these other features. Now there's a ton more specs. There's even stuff about this that's not in the specs. How do we do this? And this kind of brings us to talking about identity for different types of architectures. Now, if we want to be able to scale, then we really need to be able to understand that different architectures have different implementations, different considerations, and also different best practices. So what I'm going to do next is give you sort of a high-level overview of some of the common architectures that we see with building Angular applications. Now, in order to address this, I want to talk a little bit about securing applications with cookies. And this was very typically done, is still typically done with server-side applications. So this would be apps that are built entirely in .NET or Java or PHP, traditionally back-end technologies. So what this looks like is you have your browser, your user's looking at the browser, and then on the server you have a back-end web app, and maybe it gets its information from a database. Now, in our scenario, we also have this authorization server. Now, when the user logs in, a request is going to be sent to the authorization server, and then the authorization server, in its turn, is going to verify that request and then issue an ID token to the application on the back end. Once this happens, then the server is going to set a cookie, and the cookie represents this user's active session. At this point, we can consider the user logged in or authenticated. Now, whenever there's any traffic to this domain, when the user makes a request for a web page, then the cookie is going to be sent to the server from the browser, and the requested data can be sent back from the server and shown to the user in the browser, and this might include any kind of sensitive information, anything that needs to be behind a login. We've got that cookie. We know that we are allowed to show this user any kind of sensitive data that they're requesting. Now, with Angular, we build single-page applications, and the common use case for securing single-page applications is with token-based authentication. Now, this looks a little bit different from the cookie-based auth approach. We have our browser, and our user's looking at the browser. And then when the user comes and types in the URL to our application, the app is going to be compiled, downloaded, and then it's going to run inside the browser itself, not on the server. Now, our resources live somewhere else, probably, in an API. And then we have our authorization server. So when a user wants to log in, we're going to tell the authorization server, I want to authenticate, and I also want to get access to resources. The authorization server is going to issue tokens at this point, and the tokens are going to be delivered to the application that's running in the browser. The application can then parse the ID token and determine that the user is indeed authenticated, and we know who they are. And then it's going to be able to authorize access to the API resources by using that access token. Access token is going to be verified by the API, and then if it checks out, then it can send data back to the application and the user can look at it. Now, there's specific guidance for managing identity with an authorization server for different types of architectures. Now, maybe your team's application says everything is on the same domain. This is quite often the case with Angular applications. We could have an Angular app on the front end, and then a backend that is maybe a .NET backend, and the backend also provides the data, the API endpoints that the front end application calls. And then maybe if everything's on the same domain, you have your myapp.com, and then your API is located at myapp.com/API. Then in this particular case, you should consider securing everything with cookies and not necessarily needing access tokens at all. And this is actually part of current best standards practice. So if you're sort of curious about really digging deep, you can check out the links at the bottom. And what this looks like is something like this. So on the back end, you have, on the server, you've got a backend, and your backend is capable of executing code. It also is providing data, so it's providing API endpoints. Now the backend serves the Angular application, which then runs in the browser. And then there's this authorization server hanging out somewhere, right? So we can actually log in using the backend, using routes that are provided by the backend itself, and then the backend application can interact with the authorization server to log users in. Then any data that's moving between the backend and the Angular application that's running in the browser can just be secured with a regular session cookie. And we don't need to worry about sort of passing access tokens around or trying to keep them safe in the browser, which is inherently a very unsafe place. But maybe this isn't really an option for you. If you really need to scale, maybe you know that you're going to need to call third-party APIs in the future, or maybe you already do. Maybe your API and your application actually don't live on the same domain. Then in this case, you're dealing with cross-origin resources, you're going to need to scale up, you should use tokens in this scenario. So I talked a little bit about the existence of best practices and how open standards give us best practices. Now, the standards and specifications are updated as the web evolves, and they're sort of stewarded by organizations and groups of individuals whose primary drive is to make the web a safe place. So they can deliver best practices, and these can change periodically as time goes by. Now, especially with something as sensitive as authentication and security, it's really important to know about the best practices. And in fact, there are now new best practices for JavaScript applications that were drafted in early 2019. But the thing that happens to us, and it happens to everybody, managers and also developers, is keeping up with all of these changes can really feel like this rat race, especially when the bulk of your time and the core of your engineering work really needs to be working on building a fantastic product, adding features, or maybe launching a service into production. And the new best practices for single-page applications are complicated. They look like a lot of work. They have a bunch of new moving pieces. There's like hashing methods and multiple exchanges with the authorization server and things like that. But the thing is, you can kind of offload all of this. Now, identity services provide tools, SDKs, that can do all of this work for you. And the authorization servers that are provided by identity solutions work really hard to keep up with evolving best practices to make sure that you don't need to get bogged down with worrying about it. They provide libraries, they provide compliance measures on the platform side to keep you up to date, and they provide libraries to you so that you can easily just plug and play in your application and have this work and be up to date. So in our conversation so far, I have talked about an introduction to identity, sort of as a high level to demystify some of the terms. I've talked about open standards, for example, like OAuth 2 and OIDC. I also talked about standards-based authorization servers and how doing something like this can really get you to a situation where you're more able to scale easily, as well as the different architectures that are common in the Angular landscape. And finally, we touched a little bit on best practices and sort of the idea that we don't need to be terrified of changes in best practices because there's ways to address that sort of more in a more approachable manner. So this whole thing really still only needs to be a two-step process if you just use an identity service. Only now you have a much better idea about how to get your teams from those sort of two circles to this beautifully, fully shaded, wonderful work of art at the end, and you have more context on the surrounding ecosystem there. So I hope that this session has sort of helped you to demystify some of the identity concepts so you can better understand the landscape that we're in when we start talking about identity. And of course, I'll be around. If you come talk to me, you can get a point towards the winning that wonderful stay at Breckenridge. And so if you also want to get in touch later, if you think of anything else, have any questions, I'm pretty active on Twitter, so you can always reach out to me there. The slides for this talk are available at this link, and I really appreciate your time today. So thank you very much.